Alright, today we are going to be working on solving our quadratics by taking square roots. So this is what we have done before. So far none of these are new. Now as we are watching a video, please keep in mind that you need to hit stop and pause and rewind on anything that you do not understand. So on this guy right here, we are going to add over 25 to the other side. And we get out x squared is equal to 25. So we go to take the square root. And what times what gets us to 25? And that is 5. And we list out our two answers, a positive 5 and a negative 5. Whoop. Negative 5. Came out funny looking. All right, number 2. I picked this number specifically because as we add over 19, we get x squared is equal to 19. And when we take the square root, we do not have something times something getting us to 19. So we are going to list out positive root 19 and negative root 19. Now I picked 19 specifically because it is prime and there are no factors that will get us to the 19. Okay, now if we do have another number, for example, like 2x squared is equal to 90. We have an extra step on this one actually. We're going to divide out that 2 to get the x by itself. We're going to get x squared is equal to 45. And we go to take the square root on both sides. This guy is not prime, so what we need to do is we need to simplify him. And that is what I'm going to take a quick break from doing on this problem. So we're going to finish it in just a second. X equals something and something. And we are going to learn how to simplify these square roots. So new section, simplify square roots. So we tend to do this if we notice that they are not prime numbers and they have different factors that go into them. So there are two methods that we are going to use. So my first example is going to be the square root of 12. Now, method 1, you are going to think about perfect squares that go into 12 as a factor. So perfect squares are 4, 9, 16, 25. And the number I am seeing as a factor that will go in is 4. And it's 4 times 3. So we're going to rewrite the original problem as 4 times 3. Both with square roots on them. And then therefore we know the square root of 4, and it is 2. And we leave it 2 square root of 3. So there's our final answer. Okay, number 2. Actually, not number 2. Method 2 is that we do not recognize a perfect square that goes into it. This will happen as our numbers get larger. So what we are going to do is we are going to make a prime factor tree. So I'm going to start with as low as I can go. Here's my prime factor tree of 12. And what's the lowest number that can divide it is 2. 2 times what is 6. Okay, and 6 divides again by 2. And we get out 3. Okay, and 3 doesn't divide by anything. So across the bottom right here is my prime factor tree. 2 times 2 times 3 is 12. Okay, so what I'm looking for is a pair, and I see a pair right here. And if you can see, that's my square root of 4 right there. A pair says I need to bring one of the pairs out. I'm taking the square root, and then I leave whatever is left inside. And I get to the same answer. So we circle the pair, and we bring one out. Okay, hit pause and make sure you have all this written down before we go on to number 2. Okay, number 2 is the square root of 50. Okay, so again by method 1, which of these numbers go into 50? And I'm seeing 25. Okay, so by this method I'm going to rewrite it again just so it's underneath the old one. And we have 25 times 2. Okay, so we bring out 5 and we leave in 2. By method 2, I'm going to make my prime factor tree. Maybe I don't recognize what the biggest perfect square is. Okay, so we get 2 and 25, 5 and 5. 5 doesn't divide by anything, so I bring it down and I'm going to double check. 2 times 5 is 10, times 5 is 50. Okay, I'm going to look, see a pair. So the 5 comes out. And this guy is a single and he stays in. Either way, we get the same answer. All right, take a moment and pause before we go on to number 3. Okay, number 3, square root of 48. So, most times, students don't recognize on this number the biggest perfect square that goes into it. So a lot of times they start with 4. And we get 4 times 12. And then we simplify it down to 2 root 12. Okay, but then I'm staring at the 12 again. I'm like, wait a minute. 4 goes into the 12 again. So we have 2 and 4 times 3. And then we take the square root of 4. And we get out 4 root 3. So this method works even if you do not take out the biggest perfect square. So in fact, the biggest perfect square that comes out of this guy is 16. So sometimes students do use their calculator and they guess at the biggest perfect squares before they get down to the 4. Okay, and we also get 4 root 3. So this example is good for a couple reasons. 1, you may not recognize the biggest perfect square. 2, if you have a number in the front, you're going to keep moving with the problem and multiply by the number out front. Okay, I'm going to show this by method 2. Okay, so 48 divided by 2 is 12. 24. Whoa. Okay, divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. Nothing else divides, so I'm going to bring it down. There's my prime factoring. Okay, and then this one I see a pair, so 2 comes out. I see another pair, so 2 comes out, and the 3 stays inside. So then we go ahead and finish this out. Outside numbers get multiplied together, and we get 4 root 3. Awesome. So all the different ways to do that. Okay, we are going to do one more, and I'm going to make sure pretty much we know that we do not know this one off the top of our head. I'm going to go really high up there, 294. Woo. Okay, I do not know the perfect square that goes into this. I am instantly going to go to method 2, and I'm going to do 294. Now it ends in a 4, so I know it divides by 2. So 294 divided by 2, and I get out 147. Okay, that does not divide by 2, so I'm going to try by 3, and I get out 49, and I recognize the perfect square right there, which is kind of nice. Okay, and then we get out 7, divides by 7, we get out 7, and bring down the 7. 2 times 3 times 7 is 249. So I may not have known this one from the beginning, but there's my pair, and I'm going to bring out a 7, and both of these are on the inside, so I'm going to multiply them together, and I get 2 times 3 is 6, and we are done. Now, you may not feel like you know if this is the right simplification. So a quick check is that you type in square root of 294 to your calculator, and you'll get a decimal about 17.1. And if you type in 7 root 6 into your calculator, you also get a decimal that's 17.1. So these should be equivalent of simplifying our expressions. So that would be a way to double check, because you cannot plug that back in. All right, I'm at the bottom of my page, so go to the next page, please. And we're just going to do a couple more before I go back to that number 3 at the very beginning. So we are now on example 5. And I am going to throw a letter in there, a to the 5th. And this is no different. We're going to make a prime factor tree, and it's going to be a times a times a times a times a. Look at that prime factor tree, and we're going to do the same thing. I find a pair, and a comes out. I find another pair, find another a comes out, and this guy stays inside. And then I'm going to simplify it. A times a is a squared, root a. Nice. Okay, take a moment and write that down. Okay, number 6. Square root of 9b to the 3rd. So I gave you this one specifically because hopefully we are recognizing the square root of 9. And the square root of 9 is 3. So let's go ahead and take out the 3. And then we're going to deal with the b. So here we go. B times b times b. Find a pair. One of them comes out. And this guy stays in. Not too bad. So let's rewrite our final answer. 3 is on the outside. B is on the outside. 3b root b. Final example, number 7. Square root of 30 c to the 4th. Okay, now 30 is not a perfect square, so we got to do a tree. So I'm going to come over here and do a tree. And I see 2 and 15, 3 and 5, and the 5 comes down. Instantly I am noticing no pairs. This does not simplify, and we leave the 30 on the inside. Okay, I'm also going to write out times c, times c, times c, times c. Now I start to see some pairs. One of them comes out. Another set comes out. No pairs over here, so these all stay inside. 2 times 3 times 5, which is the square root of 30. Simplifying it, c squared root 30. And we are done with that one. Now, I do have a note on Math Excel. If you were to get a problem that says square root of 30, you would answer it, it does not simplify. For me, you would just say, here's my answer. It's the square root of 30. And that way I know you know it does not simplify. All right, so where are we going with all of this is coming back to the original. Our whole goal is that we need to solve these quadratics so we can work on graphing them next chapter. Okay, so either you know the square root, it's a prime, and you write plus root and minus root. And if it's not prime, we need to work on simplifying it. So this number was a 45. So I'm going to make my tree. It does not divide by 2, so I'm going to try by 3. And I get out 15. It divides by 3 again, and I get out 5. And then bring down the 5 because nothing divides. I'm going to double check. 3 times 3 is 9, times 5 is 45. So I see a pair, a 3 will come out, and a 5 will stay in. So coming back up to this, we are going to write positive 3 root 5 and negative 3 root 5. And this is how we answer things, or at least check, when they are not prime numbers, or we do not know the roots. Okay, so we are going to be doing two things today. One, we are going to do a quizzes review. Okay, and I'm going to write the quizzes code on the board for you. And then two, you are going to work in Math Excel, and you do need to show your work. So make sure you are writing in your assignment notebook, because you need to be showing me these trees. And these are the two things I would like done by the end of the class period. So budget your time wisely. Now, quizzes review. You have to get a 70% or more, or else you need to log back in for me. Okay, Excel, take your time and do similar problems. And good luck with that. All right, heading out. Goodbye.